Hey guys, welcome to System Design Fight Club. I'm now going to go over chapter 9 for my predictions of Alex Shu's upcoming book on ML system design. The chapter is similar listings on vacation rental platforms. I'm just kind of using Wikipedia for collaborative filtering to give it my best guess as to how to do some of these. So the requirements are going to be that a user can view a listing, and then they can see similar listings. And I'm pretty sure he's not going to cover this, but I am. It's that new listings can be added and it'll update the similar listings as new listings are added, as opposed to being a batch job. On Stay, I'm going to kind of have them as close to real time as possible, which will maybe have a little bit of discrepancy at first until the next iterative big batch job happens. So let's talk about the data model. I'm feeling that it'll probably be another, well, so it's a recommender system, and then it's collaborative filtering. And it's probably going to be item based. In fact, I'm thinking it's this thing where it's item collaborative filtering. So you given a specific listing, show the other listings that are similar. I'd imagine that it's going to have pretty low user data. There's probably not like a ton of people that are just booking listings all the time. So it's probably a pretty ideal case for item collaborative filtering, I think, where you're going to look at the similarity of the listings. Another approach is that it might, for the online, you can possibly do neighbor-based, also known as memory-based, collaborative filtering. And that'll be with a classifier. So for this first one, it's going to be clustering. That's how I'm going to do it. There's a couple of different algorithms that you can use for that. So there's k-means, there's you have Birch, there's dbScan, I think is pretty fast, or Birch. One of those ones are some of those last three are pretty fast from what I remember. It's been a little bit of a while since I've done any stuff with clustering. I took a couple classes on it in college. And then for the neighbor-based or memory-based one, that would be classification. And I think you can actually do something like K nearest neighbors. So KNN, K nearest neighbors, is what I'm thinking for that. I think that is all I really wanted to cover. Oh, it was so for item collaborative filtering. This is kind of invented by Amazon.com for show similar products. So like, hey, we see that you're looking at product X. Here's some product Y that other people have bought when they were looking at this product X. So it kind of came out of Amazon.com. Yeah, it kind of made it most famous. I don't think I have anything else to say about this, so we can probably go ahead and jump into the diagram. So we're going to start off with just these two scenarios at first. We're going to look at a user that is viewing a listing. So user views a listing. Let's see if it'll show up right. Awesome, cool. And then we are going to have the listing service that is just going to map to from a listing ID to a the details for it. And then I'm going to have I'm going to split it into two services so that like it's kind of how it would kind of work with React.js, where you can make like multiple backend calls while loading up a page. The first one's just going to be the listing service. Another one's going to be the listing recommendation service. You can kind of, you can definitely merge them, but it would make this a little bit more confusing to explain how it like works. So this one will take a listing ID, and it'll return back listing info. It's just like the rest of the details for the listing. And then this one, given a listing ID, returns back a bunch of other listings. So you give it a listing ID, and then it returns a list of listing IDs of similar listings. So this one's just going to have our listing DB. It's going to be really straightforward how this one works. It's just the listing DB. Oh, hello. And so the schema for that one, again, super straightforward. Going to have a listing ID for the one that you want to look at, which would be something like 3470. And then it'll have stuff like the lat longe. It could have listing name. Whoops, I meant to say resort. Cool. Yeah. And so this would just be the primary key. So partitioning key and primary key. Very straightforward. Yeah, okay. So you have the listing ID, you're going to pass that into the listing DB as well, and it's just going to have the listing details. Cool. All right. And then this other one is going to be what's a little bit more tricky. It is the listing rec DB. And I'm going to do that square table thing that I did before to help illustrate what's going on with this. So we're going to have columns are listings, and the rows are also going to be listings. So you give it a listing ID, and then there'll be certain columns that are very similar listings. Okay, and then how are we going to get this thing? Well, so I kind of want to draw the arrows for this first. So how are we going to get this thing clustering? So we're going to take all the data from this, and we're going to run our model training workers against that. You don't want to do that right against prod. So this is an OLTP database. You don't want to run it straight against that. So you should actually probably be keeping a copy over here. Let's say it's like OLAP, or it could just be the data warehouse, which has like a whole bunch of different tables in it. So you have this, and then we are going to have CDC with DB triggers. Okay, and then we can have our training model that pulls that in and does a thing. So model training workers. Okay, and you can do like an ETL thing. You just got to get whatever it is that you're going to try and cluster all onto the worker. And then it's going to have this clustering. It'll make clusters of just like groupings of listings that are similar to each other. So there's another thing that I'm expecting to see in this chapter is similarity, or it's also called distance metrics, I believe. So there's Manhattan distance, there's Euclidean distance, oops, Euclidean distance, there's Minkowski distance, whoops, Minkowski distance. You also have cosine similarity one. It's sometimes they say similarity metric, sometimes they say distance metric. I've heard it both ways. I think that's most of them. But that's you would pick a distance metric to use or similarity metric to use for the clustering algorithm. You can specify it. If you have really high dimensionality, this is a really bad idea to use. You can get an overflow on it. Yeah, so I expect this to get mentioned somewhere within the book at least. It should probably be anywhere that you see clustering. You should probably see this pop up. So you got the groupings of the listings, and then you will like output, you need to capture it somewhere. So this is an OLTP database. You don't want to write directly to prod. So that's why I'm still going to have, I'm going to call it a model store. It still is it's probably an object store. Meaning it's S3 or holding it. So you can have this big thing of groupings of listings, and then incrementally you can copy it over to the OLTP database. You don't want to do it all at once though, because then you're just hosing prod. You can also store the model version. So each model could have like a version for like A/B testing. A/B testing should definitely get brought up in this book. I'm going to be really shocked if it doesn't. Yeah, that'd be kind of crazy. So incrementally, it's just going to write one record at a time over to here. And then I don't think you necessarily have to have every single listing ID for each individual one. So if you have like 1,000 listings, I don't think you really need to have 1,000 columns. Let's talk about the schema really quick then. So you would have, again, your listing ID, just like 3470. And then you would have similar listings, and you can just have the ones that are actually similar. And you can crank up you might be able to specify the threshold or like do some kind of tuning with the distance and some kind of parameter of your model so that it's not giving you like 100 similar listings. I'm sure there's some kind of tuning you can do there. 2, 4, 7, sure, that looks right. So you just have a listing of several that meet whatever threshold for distance metric. They're similar enough to be in the same group. And that's what you have over here. Okay. So I wanted to also cover when new listings are getting added. So let's zoom out. Let's specify that. So this is running clustering. And so like an example of that could be k-means. It could be, I'm pretty sure DB scan is rather fast. So we'll just say that. Or you can even just say, I think clustering would make that the most clear. It doesn't matter what clustering algorithm, I don't really care. But you need to know that's a clustering problem. Okay, and now we're going to look at how to add the extra feature. Well, okay, before we do that, I usually have been specifying what the data model has as input and output. And in this case, the data model is going to be literally what you have here in the database. The database directly is going to be the data model with how we have it set up. You don't have like a pickle object like I have in some of the other problem solutions that I've written. It's like just the database directly is the data model. Whoops. Let's talk about the input and output. I'm trying to specify this for every single problem because I've been annoyed by how some solutions online don't specify it. So I'm definitely specifying it for all of my problems, even if it's really straightforward. It's literally a listing ID in and then a list of listing IDs out. No feature values, no feature conversions. You don't use the user profile. So that's one of the trade-offs of using the current approach that we are using for this one is that it doesn't really have user preferences. You could maybe get around that and you might be able to do something like doing what is it, implicit. Okay, that could be something that will come up is implicit data collection. It's either the word collection or gathering over listing views, and those could be used as actually let's just keep on. Those could be used as the class values for training a classifier. So there's some way to make it work as a classifier for making the and then switch over to something where it has user preferences taken into account, because right now all the users are just indistinguishable. I'd kind of be surprised if that approach is taken. So I don't think Alex is going to do that. So that would be call that personalization. Right now it's not personalized. It's not you don't have personalized results. Everyone's results look the same whenever you look at an item. Yeah, so there's a way to force personalization though. Okay, let's look at how this would look if you are going to do the online like trying to do real-time adding of new listings to the similar listings. So like somebody adds new listing and it starts showing up in similar listings right away. So let's make a little space. And it would not be the same user doing this. It would be the rental owner. So user adds a listing. You would have new listing service, you could say. And it would go straight to the listing DB. You have your information you entered. You're going to write it straight to the listing DB. Listing DB gives you a 200. It's like, yep, success, recorded your record, comes back. And then, so right now, it would have to wait for the next model training to occur for the clustering algorithm, and that can be really expensive. If you're using DB Scan or one of the faster ones, one of these last three, I think they might actually be able to run in big O of n. One of them is probably n log n. I'm pretty sure some of them are n squared though. There's at least one clustering algorithm that's n squared. I'm pretty sure clustering is not necessarily the fastest thing in the world. Neural networks give output really fast. They take a while to train, but they give output pretty fast. You can't add new data points to a clustering model without just retraining the whole thing over the entire data set. So that's not fun. So alternatively, we're going to have it do this like classification trick. So we have this, and then we're going to have this like classifier thing. It's going to be running k-nearest neighbors, which is where it looks at the k most similar classifier task owners. It looks at the K most similar listings. And based on what clustering ID that they have, it puts it into the same, it puts it into the most popular clustering ID, grouping ID among K many nearest neighbors to that listing ID. So that's one way to hack it to being a little bit more real time. So you have that, and then it will do a write operation straight over to there. It probably should be pulling in some data from the listing data store, or no, it needs the object store. Yeah, it needs to have the current model. Or can read. No, it does need to, yeah, okay. Yeah, that should work. Okay. Was there anything else that I wanted to do for this? I think we're good. Yeah. All right. So that was chapter 9, similar listings on vacation rental platforms. Thanks for watching. I'll see you guys next time. Thanks.